got really interested in was the fat solubles, because I knew they were poorly absorbed. Vitamin A, vitamin E, beta-carotene, vitamin D, vitamin K, and a whole bunch of other things, fatty acids, some of the things that you now know as important in tomatoes like lutein, lycopene. All those things are fat soluble, which means they're oils, which means they don't get well absorbed. And the reason for that is the body uses a water system for transport. So your bloodstream is water, your tissues are water, in and out of cells are water. So if they're all water, how do you get oils to go in? Well, the body has a unique mechanism to do that. It's called forming micelles. So micelles are a natural process of the digestion that occurs in the body. And what that really means is you take a great big blob of oil, and the body, through pancreatic enzymes and bile acids, breaks that up into a tiny little particle called a micelle, which is really a little blob of oil that's now reduced to a tiny, tiny size. And then it's surrounded by water. So now the body can actually pick it up, transport it, and use it. That's a normal process, but it's not necessarily very efficient to do that. So the thought was, well, if that's really what's going on, and by the way, let me tell you what a micelle has to be obviously smaller than a red blood cell or anything, otherwise they keep slipping in and out of, of the vessels as well. So what I thought about is, well, what if we create a system where we make a micelle out of fat solubles in advance, that is, before you take it? Is there a way to take a fat soluble material, put it into a micelle, so that you now have it in a water solution? And the answer is yes, you could. That was done a lot in other areas of chemistry. So I thought, well, why not for nutrition? So what we did is we came upon a method of being able to take a fat-soluble oil, break it up into a tiny micelle by using some naturally occurring things and actually making that particle size very, very small. We were able to do that, and the particle size we were able to come up with a lot of work, and even now, even better, is something that's in the range of, this won't mean much, but I'll explain it to you, 0.05 micron to 1 micron. Now, you say, well, what the heck does that mean? But rather than me explain it to you in terms of meters and feet and inches, let me just tell you that a red blood cell is about 10 microns. So what you're talking about is something that's 1/200th to maybe about 1/10 the size of a red blood cell. So you're trying to get things that are 1/100th the size of a red blood cell so that it can properly transport. So that's what we do when we create the concept of a micelle.